what we were doing about the circuit. In the first thing, there are two types of current. One is the alternating current. One is the alternating current. Just once I'll revise and you sit no Lakshmi. Another one is the direct current. One is alternating current, second one is the direct current. And in our home appliances, what we get, or from the power station to the main switch, whatever we are getting, the current is the alternating current. Okay, it is the alternating current, and its frequency is 50 hertz. Its frequency is 50 hertz. Its voltage is 220 volts. Okay, its voltage is 220 volts. It is not actually the peak voltage, it is the RMS voltage, RMS value. We call it as the RMS value. Okay, sometimes they ask this voltage, it is 220 volts, it is the RMS value, not the peak value. It is some, see, it is, 1 minute, I will tell. See, what is that? Current is continuously varying like this. Think, for example, it is 5 amps means, or voltage, if it is considering 5 volts voltage. Okay. So, voltage is continuously varying from 0 to 5, 5 to 0, then it changes its direction from 0 to -5, -5 to 0. Like this, it will change. Okay. Peak value means that is the highest value, how much it will go, that they call it as the peak value. So here if I'm considering +5, that is the peak value. And what is that peak value? That they also call it by amplitude. It is called it by amplitude. And number of cycles per second, we call it as frequency, that is in hertz, that is 50 hertz. Okay, RMS value means, see, continuously if it is changing, how much is its value? That is, instead of AC, if you have applied for the same time the direct current, how much current it would have been utilized? Okay, if I consider, I want to know. Sit here, na? Here or here? Okay. So instead of alternating current, if I'm using the direct current, how much would have been if because it's continuously varying? No, we will not be able to know that value. Like how to for whole cycle, how much would have been the value that they calculate? That they call it as the RMS value. Okay, that value is 220 volts. More than that, it is there. Next classes you can study more than that, to derive that and all is there. Okay. So then we studied it as a parallel circuit. We studied it as parallel circuit. Okay. A parallel circuit. Why it is a parallel circuit? Netra, can you tell? Home appliances, all the appliances, bulbs, TVs, everything, they are connected in parallel to each other. In home appliances, they are connected to parallel to each other. What is the reason? They are all connected in parallel or like this. So that whenever there is some appliances, if one it is, it will not work. If there is a open circuit in this, so all other appliances can be used because the circuit still it is complete. If it is not there, then this whole thing is a circuit, still it is there. But in a series, if there is some open circuit, then there is no continuous path, then there is no current flow through this. These questions they will ask, why parallel circuit, all this. Okay. So there will be no continuous path for that, then all the appliances will not work. It is very bad, right? One bulb is not working, then whole thing it doesn't work. So we always use the parallel circuit. That is the first one. Okay. Second one. No, sit there. Sit na. Why you want? Okay. Now, that is a one thing. Second one, resistance. Okay. Second one, resistance will be less in the parallel circuit than in the series circuit because in the series circuit, resistance adds up. Whereas in the parallel circuit, we know that resistance will be very less. So that is the second thing. Third reason is voltage. All the appliances will get the same voltage, that is the 220 volts. Okay, so these are the three reasons which they are connected. All the appliances in the home are connected in parallel circuit. Okay, so this is the one. Next, we are using the fuse. Okay, why we have to use the fuse? Shall I clear this? I think everything we have written no, yesterday. Just
So everything in a house is connected with only parallel circuit. So the fuse is always connected with series, right?
Correct.
How do you, when I use is connected in series, the rest of the appliances are connected, so it's connected in series, it will go to all, I mean, all the other circuits, series, and then it's parallel.
Both, usually any circuit, everything will be there. Series, parallel, everything it should be there, right? See, it is like this. Appliances will be connected something like this. Each one thing, it's like this. It will be connected. In the main switch, there will be different wires. Okay. The first one, they call it as the live wire. Okay. It is red in color. Red in color. And when they are building a new house, they will put the wires. You would have seen, like through the switches, main switch, they will put all the wires, everything through the plug points. So when you put any device to the plug point, until that there is a connection. From that plug point, it will be to the this one, like that. Okay. So it is a continuous loop. It will become that. So now, first, there are two wires will be there. One is called as the live wire. That voltage is 220 volts. Another wire, there is the neutral wire. There, the voltage will be 0 volts. Okay. And we studied about the voltage or potential difference. What is potential difference? The difference between the voltage between the 2 points, that only we call it as a potential difference. We studied potential difference, right? What is the potential difference we studied? The difference in the between any 2 points, what is the difference between them? That only we call it as the potential difference. Okay, that is only the voltage. Because if there is some difference in the voltage, okay, then only the current will flow. So that difference only we consider here, it is 220 volts. Because in the live wire, the voltage is 220 volts. In the neutral wire, the voltage is 0 volts. So what is the potential difference between these two? It is 220 volts. Okay. See, it is like water will flow. How water will flow? In which direction it will flow? From some height to the downside it will flow. Correct? Any rainwater also, how it will flow? In which direction it will flow? Wherever the slope will be there, it will flow. That is change in the height. There it will flow. Similarly, here also, whenever there is a potential difference, then the current will flow. Whenever there is a potential difference, then the current will flow. So, potential difference between a live wire and the neutral wire, it is equal to 220 volts. That is the voltage what we get in the house appliances. Okay. So, live wire always they have kept in the red color. In home also, when they are putting the wires inside the wall and all, you can observe you will have one red color, another one neutral wire, that is the black color. Okay, so that will be black color. Okay, that is the black color. It will be there. These are the two. Where we get only two wires, where you have only two plug points, no, there you will have only these two wires. When you have three plug points, right, then you will have three wires connected to that. The third one, we call it as the earth wire. Earth wire, that is green in color. That is green in color. Okay. So why it is green in color? Because it is used mainly for the safety. That is, see, in any laptop or any iron box, if you are using, there will be the metal surface. Okay. If there is some leakage, or if there is some leakage of charges, then if you touch the iron box, its metal surface, you will get the shock, right? So to avoid that, we will have the another wire which we call it as earth wire, where from the plug point, third point, it is from the third point, this will be the earth wire connection. From this point, it is connected to the earth. Okay, underground they will actually dig some portion, and that wire it is connected to the earth. Okay, so what happens when it is connected to the earth? Here, whatever the leakage will be there on the surface, that will be passed on to the earth. Whatever the leakage will be there of the charges, okay, those charges will be passed through the earth. So because of that, whenever you touch the metal surface of the appliances also, you will not get the shock. For the protection, they use this earth wire. They will put some charcoal, many things, so that it will become the resistance will be less. The charges can easily flow into the earth. Okay, so that is mainly due to the safety we use. Again, I repeat, there will be three wires. One is the live wire, second one is the neutral wire, third one is the earth wire. Live wire, the voltage will be 220 volts. Neutral wire voltage is 0 volts. The potential difference between the live wire and the neutral wire, that is equal to 220 volts. Okay, and that is equal to 220 volts. Now, the potential difference between them is 220 volts. So, what is the use of the earth wire, which is always green in color? They use the same code everywhere, because if each one is using different, when you are connecting, if you are doing in a wrong way, it will be a problem. So, in every house or any building, they use the same color. For live wire, they are using the red color. For neutral wire, they are using the black color, and for the earth wire, they are using the green color. So live wire, the voltage will be 220 volts, neutral wire 0 volts. So difference will be equal to 220 minus 0, that is 220 volts will be there. And the earth wire, it is green in color, which is connected from the plug points. That is, all are connected to one point, from there to the ground. Okay. So why it is connected to the ground? Any leakage of the charges, that will be passed on to the ground. Okay. Any leakage of charges, that will be passed on to the ground, so that if you touch a laptop, iron box, anything, metal surfaces, then it has to conduct, right? So all charges easily will be passed through that. So even though if you touch the metal surface, you will not get shock. Okay, all these things they will ask. Okay, and next we studied about the fuse. So fuse will be connected something here like this. Okay, so why the fuse is used? Fuse, it is used for the protection. It is used for the protection. That is, for some reason, suddenly, instead of 220 volts, if 300 volts comes, okay, what happens? Current also increases. We know that voltage is directly proportional to current. Correct. So as the voltage increases, current will also increase. So then suddenly, instead of 5 amps, you may get the 10 amps current. So usually the electronic devices, though, they will not take more current. Okay. So actually, how we measure means, we usually measure according to the power. That is, voltage into the current is the power. What we take, usually all the voltage will be always the same, that is 220 volts. But when you consider the current drawn by the devices will be different. Okay, so suddenly instead of 5 amps, if 10 amps current comes to the TV, what happens? It will go, it will spoil, right? So to avoid that, we use the fuse. Fuse, think if it is of 5 amps fuse. Okay, so what will happen if the current rating for the TV is around 0 to think maybe 4.5 amps or near to the 5 amps. So we use the 5 amps fuse. Okay, we what required by the TV is think 4.0 to 4.5 amps. So we use a fuse there of 5 amps. Okay, so what happens if the current is more than 5 amps? Then the fuse will blow off. The fuse will blow off. Okay, so when fuse will blow off means it will become an open circuit. There will be a metal piece there which will melt. Because of that, it will become an open circuit. And we know that whenever it's an open circuit, that is whenever there is no closed path, then current will not flow through it. Correct? Current will not flow through it. At that time, what happens? It becomes, the current will not flow through it, so our appliances will be saved. Okay, our appliances will be saved. So that is why we are using the fuse. And we studied about 5 amps fuse and 15 amps fuse ratings. Now, usually the electronic devices, lights and all, 5 amp fuse will be used. There will be two circuit, one with the 5 amps, one with the 15 amps. Okay, in the place of 5 amps, we use the devices. Okay, wherever the 5 amps is, where we will put that wire, where it is for electronic devices, computer, TV, all lamps, all these will take less current. Okay, it is around 5 amps. All will take 5 amps current. Okay, so they less than 5 amps actually. So there we use the fuse of 5 amps. There we use the fuse of 5 amps. Okay, more than 5 amps current, the fuse will blow up and it will save the electronics devices. But for iron box, fridge or any heating element, mainly wherever the heating is required, the current use is more. Okay, wherever the heating is required, the current use will be more. Mainly like the water heaters, iron box and all, there it will use more current, maybe around to 15 amps, or less than 15 amps actually. Okay. So if I put the fuse of 14 amps, if I want 15 amps, it will never come only. Correct? No. So fuse we will select such a way that it will be just a little bit 5% more than what we require. It's like that. Okay. Every time fuse will blow up, that is also a problem. Correct? No. So what we will do for the iron box and all, usually we will have what is called that some that wherever they want more current, they use that air connection. I think they will tell us for that. There you will have the plug points for that separately. Usually you will have. So wherever the heater or siren box and all you are using, there you will have that. Okay. So there 15 amps current is required. So further there will be a separate circuit where 15 amps fuse will be there. So maximum whenever it crosses the 15 amps, the fuse will blow up. Okay, so it will save the appliances. And you have to select the fuse such a way that it should protect the appliances and also it should be able to provide the current. If the current required is 5 amps, if I am putting the fuse of 4 amps, always it will not work. Or exactly maybe 4.5, what happens? A small variation also it will blow up. So what they will do, maybe if your appliances require 4.5 amps, maybe they will put 5 amps. Okay, so that only the small portion which it can withstand, it will be passed. After 5 amps, it will blow up.
I don't know, like the fuse when it blows up when let's say 220 300 volts. So what causes the sudden change in the temperature?
Many reasons can be there. Okay. In the power, see, sometimes from the power stations, it will be supplied to every house. So, if supply use is only very less, then high voltage can come. That chances are also there. That is, minimal usage should be there. If that minimal usage is reduced suddenly, usage is suddenly reduced, the voltage can increase. That can also happen. If there is a short circuit, there can also it can increase. So many reasons.
So if there's a short circuit in a certain place,
No.
it catches fire and
No, it is not like that. I like resistance becomes very less. So current increases suddenly. Because of that, heat it will catch fire. From the fire, it will not become the open circuit. Short circuit means suddenly what happens? Resistance becomes correct. Live wire and the neutral wire, they come in contact with each other. At that time, resistance becomes very less. And we know that what is the voltage is equal to current into resistance. Resistance becomes very less, then current increases enormously. Suddenly, current increases, what happens? Heat increases so much that it catches fire. Okay, that is short circuit. In that case, also, it may, so there the fuse can blow. Nowadays, we use the MCBs, no? It will trip. That means it is actually switch off the connection. Okay, we will use that. And what does the fuse made up of?
The low melting.
Section. Fuse is made up of what?
Fuse.
Of which alloy? Lead. It is made up of tin and lead. Okay. It is made up of tin and lead. Okay. So it is alloy made up. It is made up of tin and lead. Okay. It as the its temperature increases, it has low melting point. If the temperature increases, what happens? It will melt. Okay, and they will adjust such a way that for 5 amps, if it is a 5 amp rating fuse, for that it will get the heat that much which has its melting point. Like that, they will adjust. And
Correctly, just.
yeah, I agree. Okay, understood now? I think we finished this. We'll start with the area related to circles. Read once home circuit everything. Overloading part is there. We didn't write also, I think, no? Short circuit, everything. Okay, we'll write. Short circuit, understood, no? Short circuit means, again, repeat, neutral wire and the live wire, when they get connected, what happens? Suddenly, resistance becomes very, very less. Okay. Suddenly, resistance becomes very, very less. At that time, whenever the current resistance becomes less, what happens? Current increases enormously. So then the appliance, because of that, heat is produced so much that it will catch fire. Okay, it will catch fire. And we learned something called soda extinguisher. Do you remember soda extinguisher? In the acids and bases, I think. What is that made up of? Hmm. What is that? It is made up of, do you remember? Sodium carbonate, sodium bicarbonate, and all it can be used. It's used in soda extinguisher. Do you remember? Which one will be used whenever there is a short circuit? What is the reason? Because in the short circuit, it is, see, water, if you use the water itself is a conductor. It may, problems may be more again. That's why at that time they use that soda extinguisher. Distilled water. Getting distilled water will get difficult.
What is
Okay, so sodium carbonate or sodium bicarbonate, if you use, when it is heated, what happens? It will produce carbon dioxide, which will work as an extinguisher. So in these cases, they use that. We are putting it to fire now. Okay, understood now? And can you tell anyone about overloading?
too many appliances that are disconnected and has used at the same time and too much
Correct.
it's flowing through the wire.
Overloading means when you are using many appliances together, and the wire, say, they usually they will tell like 1 kilowatt or 5 kilowatts. They will give whenever they are giving to the houses, depending on the number of houses there, everything. So if you are using the wire which can take the load of maybe 1 kilowatt. But if you are using 2 kilowatts or 3 kilowatts, there also it is overloaded. Okay, then what happens? It may catch the fire. Overloading is where you are using more current. Whereas short circuit is live wire and the neutral wire, they connect to each other where resistance becomes very less and current flows more. Same voltage, if resistance decreases, current increases. That is the one that happens because of the heat will be produced so much that it can catch fire. Area related to circles. Mohita, be quiet. Area related to circles. Ah, listen now. Listen here. Now, in the circle, we know radius, diameter, and then the sector. First, we'll study about the sector. Write down this sector. So here, OAB is a Bihan. What is the problem there? Be quiet. OAB is a sector. Okay, now we will study about the next chapter, area related to circles. Okay, so as the name itself, we are trying to calculate the area related with the circles. Okay, the first one is here I have considered a sector. So what is a sector? Sector means when between the two radius and the arc, between two radius and the arc, what is the area you have? That we call it as a sector. Again, I repeat, see, between two radius and an arc, whatever the sector we get, that whatever the portion of the area you will get, that they call it as the sector. Okay. In that, we have the minor sector and the major sector, minor sector and the major sector. So minor sector means smaller portion of the circle. Minor sector means smaller portion of the circle. Major sector means larger portion of the circle. Okay. So if I consider this point as C, now OAB is the minor sector. Okay. OACB is the major sector. Again, I repeat, in this chapter, area related to circles, we try to calculate the area. Okay. So, in that first area of a sector, what is a sector? It is the area, some portion of the circle where, okay, it is between two radius and an arc. Between two radius and an arc. So, it is called as a sector. Okay. So minor sector means smaller portion of the circle, they call it as minor sector. Larger portion of the circle, they call it as a major sector. So minor sector here is what? OAB. Major sector will be OACB. This is the one. Write down this. Huh. Write this. Okay. Now, segment. Which is a segment? Any chord and an arc makes a segment. That is, any chord of a circle and a segment and an arc together makes a segment. In this also, minor segment and major segment. Okay, minor segment and a major segment. Minor segment and the major segment. So minor segment is what? Smaller portion of the circle. Major segment is the a major portion of the circle. So this is the minor segment here. And this portion is the major segment. Okay. Write down now area of a sector. Area of a sector. That is equal to theta by 360 into pi r square. Okay.
No, why did the
Length of the. Write down this.
this is three? Yeah, it is. What is this?
Length of the arc. Then what is it? Third one. Area of the segment. Huh. Write down this. Here we will end the today's class. Do not forget to subscribe the channel. If the content of this channel is useful, please like the video and share with your friends. Thank you.